Okay, this is the foldable for our Unit 9. And the first thing I want you to do is actually write your name here. And remember, there's 400 geometry students, and they all have foldables that look exactly like this. We're going to let you use this foldable on your knowledge checks and your tests. And remember, your test is going to be after spring break, so you've got to keep up with this. So you need to put your name on it, so in case you lose it, you can get it back. And then on the front cover here, we just put a couple of little notes to remind you. Remember, the hypotenuse is across from the right angle. It's the longest side, and I still see some people having trouble finding it. Remember, it's the one that's across from the little box. The other two sides are called legs. If you didn't know what they're called, those are legs. That's the hypotenuse. Now remember, the angles in a triangle, they add up to 180, and if that's 90, that means these two have to add up to 90. That's why we put the little note here. And two angles that add up to 90 are called complementary. So this is all stuff we've talked about. It's just a little reminder of that stuff. Now this first page is absolutely a review of Pythagorean theorem. Here it is. Remember, C is always the longest side. And make a little note here just so you don't forget. And again, if you have trouble finding it, some people have trouble telling which side is the longest. Remember, you find the little box and it's the other side. It's the one that doesn't touch the 90-degree angle. A and B, it doesn't matter which one I put on these. It's just C that matters there. So we have two kind of problems. One where we're looking for the hypotenuse, where I know the legs. So this is one where I have A squared plus B squared equals C squared. I know 5 and 10. Remember, it doesn't matter which is which. So just put this right in your calculator. You get 125. But this side is not 125. I still have to do the square root. And the square root of 125 is 11.18, and for this unit we're going to round everything to 2 decimal places like that. The other one is where I'm looking for one of the legs because I know the hypotenuse in the leg. Remember, the longest one, this is C, just like here this is C. So I'm still plugging these in, but this time I'm going to plug C in, 10 is C, and these two, it doesn't matter which is which. Go ahead and square them. And then remember, on this one up here, make a little note, on this problem we added, and on this one, remember, this is the one where we have to subtract. So we're going to subtract 25 from both sides, and then we have to take the square root of it, and we get 8.66. Now, that part, all just straight review of what we've done before with the Pythagorean theorem, but this whole unit is about right triangles, so we have to just at least go over this, because you will see some problems where we have to do Pythagorean theorem. The next page is about Pythagorean triples, which we've talked about before. Remember, the whole thing about Pythagorean triples and what makes these guys special is these are the ones that come out nice, pretty whole numbers. On these problems over here, were they pretty whole numbers? No, look, they're yucky decimals, yucky decimals. These pretty whole numbers. That's the only thing that makes these special. What we're saying on here is if I had a problem like this where I gave you 8 and 15, and I did Pythagorean theorem, the answer would be 17. Pythagorean theorem still works on all these, it's just a shortcut. If I gave you this problem and said this is 7 and this is 25, and you did Pythagorean theorem, you would get 24 for that one. Multiples also work. So I can take this one that's 3, 4, 5, and do it down here, 3, 4, 5. If I take these and multiply them times 2, so each of these times 2, I could also have a 6, 8, 10 problem, and it would still work. I can multiply these times 3, 9, 12, and 15, or times 4, 12, 16, and 20. Any multiples work. I could also do it with this problem. If I had a problem where this was 14, and this was 50, I'd know that this side was, well, these are multiples of 2, so this side would have to be 48. You can check it with Pythagorean theorem, you get the same answer either way. We talked about these a couple of units ago. This is just a review of that. So now we're actually going to get to the new stuff, this 45-45 triangle. And these next two that we have here, 45-45 or 30-60, these are the ones we call special right triangles. And on the 45-45 triangles, that's our first kind. So first, remember, if this is 90 and this is 45, this other angle has to be 45 so that they add up to 180. Also, if these two base angles are the same, that means these two are the same, and this is an isosceles triangle. So I can tell you it's a 45-45 by telling you one of the angles is 45, like this problem, or if I tell you these two sides are congruent, that means it's isosceles and these have to be 45. I can tell you that either way. So we're going to write out the steps for solving this problem. The steps are, label the formula. The formulas we're going to use for this are f, and f square roots of 2. That's a mirror formula for 45-45s every time. The f square roots of 2 is the one that goes on the hypotenuse. The two legs, because we just said it's isosceles, those are the same, those are the f's. So remember, this is the hypotenuse. Then, step 2 is find f. And finally, fill in the missing sides. So, that's the same steps we're going to do on every problem. So, I drew these problems out twice, because as we work these, we actually write it right on top of the triangle, so this way you can still see this is what the problem looked like originally, and this is what the problem looks like when I finish it. The first thing is, maybe you just know one of the legs. So I know just this side here. We're going to do our steps. Label the formulas. I just copy these formulas down from up here. F square roots of 2. Then we find f. This is a little like find Waldo. Find f. Look, there it is, right there. It's the only one that has a number that goes with it, so that's the one that has to tell me what f is. F is 3. So we're going to write it out on this one because it works the same way on everyone. F equals 3. So, ... fill in 3 for f. So if f is 3, this side is also 3. Remember, we said it's isosceles, so those have to be the same. And then this side here, I'm going to put the 3 right where the f is, so this becomes 3 square roots of 2. That's it. That's all you have to do to solve these problems. What if I give you the hypotenuse instead of the leg? So here we know the hypotenuse. I'm giving you this side. It's still the same steps we just did. You label the formula. So I'm going to label the formula just like I have right here. F square roots of 2. Then find f. Just like find Waldo. There it is. It's right there. That's the only number I have. That's where I have to look. Here it is right here. Now write this down so that it's real clear, because I had some people that were confused. If 8 square roots of 2 equals f square roots of 2, look at these two sides. What would f have to be so that these two sides are exactly the same? Well, f would have to be 8 for these two sides to be exactly equal to each other. So, ... f equals 8. It's the only way those will be the same. So then, fill in the missing sides. That's step 3. F is 8, this side is 8, and this side is 8. And that's all there is to these problems. Okay, now we're going to do 30, 60, 90. These problems, the steps are exactly the same. There's just different angles here. If this is 90 and this is 30, that has to be 60. Step 1, label the formula. And this time our formula is just slightly different. This is h, 2h, and h square roots of 3. Now I'll point out a couple of things. I did this on purpose. I made these h's and I made these f's so that you can remember the difference. And remember, the f's are the ones that go with the 45s. 45s have f in the name, 45f. So the F's are the ones that go with this. I put H's here, and remember the one with the square root of 3 goes with the 30 degrees. 30 degrees has 3, square root of 3 here. Does this problem have any 3's in it? No, so it does not have the square root of 3 in this one. The square root of 3 one is easy to remember. It goes with the one with the 30. So these go together. Also, my legs, this is a longer leg, and it's the one right by the 30 is where the square root goes. The square root of 3 goes right by the 30. And this is always my hypotenuse. So, step 2, find H. And finally, number 3, fill in the missing sides, just like before. So, we've got 3 kind of problems we could have here. I could give you the short leg. I can give you the hypotenuse. Or I can give you the long leg. We're going to do an example of each one. On every one of these, I label the formulas just like this up here. H, 2H, H square roots of 3. Then find Waldo, find H, here it is. It's right there, H equals 2. So now I'm just going to plug these in, and these we're plugging in just like always. If H is 2, and I plug it in to 2 times H, that gets you 4. Then I plug it into this one, and I get 2 square roots of 3. On the next problem, label the picture, H, 2H, and H square roots of 3. Find H, there it is right there, and this is a baby algebra problem. This right here, 2H equals 10. It's just a baby algebra problem. How do you solve that? You divide by 2, and you get H equals 5. So now I'm ready to fill in the missing sides. This side is H, so that side is 5. And fill it in down here at the bottom. That side is 5 square roots of 3. And finally, if I give you the long side, label the formulas H, 2H, and H square roots of 3. Find H. Well, it's this side right here. If 3 square roots of 3 equals H square roots of 3, then H has to equal 3. Now plug it back in. Plug it in over here. This side is 3, and this side is 6. That's all there is to this.